my Lagrange function would just be this. The objective function is x times y. And then you have a plus lambda times the constraint. And the constraint is just this, I minus pxx minus pyy. And then just solve it as you did before. A z sub x is just going to be y plus a lambda, or actually, excuse me, it's going to be what? You tell me. What will the next term be? Okay, yeah, it'll be y minus a lambda times p of x, right? And we want to set this equal to 0. Z sub y would just be x minus lambda py equals 0. And finally, z sub lambda would just reproduce the constraint. Now we take these two conditions right here, solve for lambda. Same thing we did before. The only difference is before we had specific numerical values for I, px, and py. That's the only difference. So what we're getting now is a more general result. So from these two equations, what you get is lambda equals, bring this lambda px over to the right and divide by px. So you get a lambda equals y divided by the price of good x. From this equation here, bring this lambda py over, divide by py, and you get lambda equals x over py. Okay. All right. Now cross multiply. Cross multiply, and you get this interesting result. Pxx equals pyy. In other words, the expenditure on x is equal to the expenditure on y. Okay. Now, take this result in, plug it into the constraint right here. And this constraint right here says I. Now in this case, let's suppose we want to get the demand function for x. Then what we'll do for pyy, we'll substitute pxx. So you get I minus pxx minus pxx equals 0. In other words, you get I equals 2 pxx. Divide both sides by 2px, and you have the demand function for good x. We'll call this x star, because this gives the optimal value of x. It's I divided by 2px. Now we're assuming, let's just assume that the second order conditions will be satisfied. So that satisfying the first order is enough. We'll go back later and check the second order conditions. Okay. This is really the ordinary demand function for good x. It expresses x as a function of I, in this case, I and px. Py doesn't appear. More generally it would, but in this particular case, it doesn't depend on the price of good y. Okay. If we wanted to solve for y star, we use the same relationship, but we just solve for pxx here. We substitute in pyy here for pxx. So you'd get I minus pyy minus pyy equals 0, or I equals 2 times pyy. And dividing both sides by 2py, you get y star equals I divided by 2 times the price of good y. That's the demand function for good y. And I think in the homework problem, I asked you, Brianna, right, to solve for the ordinary demand functions. This is what we mean. Another name for these demand functions, they're sometimes called the Marshallian demand functions, after Marshall, the famous economist, Alfred Marshall. So they're also called the Marshallian demand functions. More generally, these Marshallian demand functions will be of this form. X star equals x, where x is a function of the price of x, the price of y, and income. And y star will be some function y, which depends on the price of x, the price of y, and income. But in this special case, notice the demand for good x is just a function of income and the price of good y. Price of good y doesn't enter. But in other cases, it might. Okay. Marshallian demand functions or ordinary demand functions. It's another term used. So let me illustrate how you would use these ordinary demand functions. If you know income, the price of x, the price of y, you just plug in, and you get the optimal value of x. For example, let's consider this case right here. When I did this example in class, last week, what values did I use for I, px, and py? Does anybody remember from your notes? I thought I did this example in class for a specific value of income, the price of x, and the price of y.
It was 4 and 1.
Okay. Was the price of x 4 and the price of y 1? Was that it? Okay. All right. Let's just plug in. So suppose I is 100. Is that what I used? Or did I use 200? I can't remember.
200.
Oh, I used 200. Thank you. Thank you. Will, you take good notes. And what was the price of x again? 4. The price of y? 1. Okay, there we go. So if we use, and let me just go ahead. What does our budget line look like in this particular case? What will our budget line look like? We could very quickly determine it. We could get at most 200 units of y, couldn't we? So this will be 200. The most we could get of x would be 50, wouldn't it? So this will be 50 down here. So it'll be a straight line that looks like this. Okay. Now I know for this particular utility function, u equals xy, the optimal solution will always just be the midpoint. So it should be this point right here, 150. So if you graph the highest indifference curve, it should look like this. Okay. And this maximum utility obviously would be 50 times 100 or 5,000. Oh, you're right, because this is 50 here. Thank you, Zach. The midpoint would be 25. Thank you, Zach. So it would be 25 times 100 would be 2,500. Okay, thank you. Okay, let's see if that matches our Marshallian demand functions. It should. According to our Marshallian demand function for good x, the more general expression is I over 2 times the price of x. In our particular case, I was 200, wasn't it? and the price of x was 4. So this would be 200 over 8. And that should be 25. Yes, that looks good. Okay. A y star, according to the Marshallian demand function, is I over 2py. So this should be 200 over 2 times 1 is 2. Should be 100. It matches. It matches. Okay. So this is these ordinary demand functions are just general solutions expressed in terms of different values of I, px, and py. Okay. So I think that was the last thing you needed to know to complete your homework. So I will give you until Monday. Yes?
Will there ever be a situation where you don't give us px, py, but you give us ux, uy, and we have to figure out what those are?
No, well, I don't know. I don't know off the top of my head that I do that. But let me think about it. Okay. Before I leave this, let me just point out some things. We can actually point out several things. For this particular utility function, u equals xy. U equals x times y. Okay. We derived the Marshallian demand functions, and just to repeat, the Marshallian demand function for good x is this. X star is I over 2 times the price of good x. Or I could write that another way. Sometimes I prefer to write this way. It's 1/2 times I times px to the minus 1. And the Marshallian demand function for good y is a similar expression, only it's I divided by 2py. Or alternatively, it's 1/2 times I times py to the minus 1. Now notice, what are the effect of, how does the quantity of good x depend on income and the price of good x? Notice the optimal value of x is expressed as a function of income and the price of good x. How do those two variables affect x?
As income goes up, x goes up. As price goes up, x goes down.
Exactly right. We could express this. This is 619. So you could use partial derivatives and do really comparative static analysis. Here, the variables, in this case, px, py, and I are parameters, and x is a variable. So if you just take partial x star, partial I, notice that's just 1/2 times px to the minus 1. Obviously, this is always positive. Or you could see this more simply, probably is the way Ian got that answer. He probably just looked at this and said, as income goes up, obviously this thing goes up. Okay. Or alternatively, if you use partial derivatives, you could see this partial derivative is always positive. What is partial x star? Partial px? Well, just take the derivative of this with respect to the price of good x, and it's going to be minus 1/2 times I times px to the minus 2. This partial derivative, always negative. Okay. So in simple words, as income goes up, as my income goes up, I'm always going to consume more of good x. As the price of good x goes up, I'm always going to consume less of x. Okay. Okay, notice these are partial derivatives. So this means as income rises, holding the price constant. That has a positive effect. So we would say good X is what kind of a good? What do you know the terminology in consumer theory? If partial X, partial I is always positive, then good X is said to be a normal good. A normal good is a good in which consumption of the good and income move in the same direction. Income goes up, you consume more good X. Income goes down, you consume less of good X. Okay, so good X is a normal good. What about good Y? It's also a normal good. Because as I goes up, you can see from this equation right here, as I goes up, Y star is going to go up. Partial Y star, partial I, is just equal to 1/2 times Py to the minus 1. That's always positive. Partial Y star, partial Py is always negative. Notice that's minus 1/2 I Py to the minus 2. That's always negative. Okay. That's the law of demand. As the price of good Y goes up, consumer consumes less of it. As the price of good X goes up, consumer consumes less of good X. Now in this particular case, what if I ask you what is partial X star, partial Py? What's the partial derivative of X star with respect to Py? 0. Because Py doesn't appear. So this is 0. In other words, this says the price of good Y has no effect on the optimal consumption of good X. Also, what is partial Y star, partial Px? What is that equal to? 0. Because in this equation right here, Px doesn't appear. So it means the price of X has no effect on Y star. Okay, so this is 0. So in this particular case, the cross price effects are 0. Okay. One more thing we can do with this. You recall we talked about elasticities. Okay. And can anybody tell me what is the income elasticity demand for good X? What is the income elasticity demand for good X, given this demand function? Okay. All right. You want to give me the formula. Okay. Yes. Let's go ahead. Let's let E stand for elasticity. I'll use a capital E. So it's E sub X comma I. The income elasticity demand for good X. And the formula for this is, Jacob?
dx di.
Okay. Well, in this case, let's use partial derivatives, because Cx is a function of I and Px. So let's use partial derivatives. Partial X, partial I. Times I over X. Very good. This is the formula for the income elasticity demand for good X. And let's just find what it is. What is partial X, partial I? What is partial X, partial I?
1/2 dx minus 1.
Right. It's just 1/2 times Px to the minus 1. Now, multiply this by I over X. And I'll just put the x down here. What is x? X is 1/2 I bx to the minus 1. But look at this in the numerator. The numerator and denominator are the same. So this is equal to what? 1. The income elasticity demand for good X for this individual, for me, always 1. So what does that mean in words? Yeah, okay, it's unit elastic. And what does that mean?
As you substitute towards x, you'll get a 1% increase in price?
Nope, nope.
That's all backwards.
Okay. Intuitively, what is the income elasticity demand for good X? What's the intuitive formula for this? It's the percentage change in X. Yes, it's the percentage change in X divided by the percentage change in I. Now, mathematically, you could show that that's just this. Okay. So, if it's 1, if my income elasticity demand for good X is 1, what does that mean?
As your income increases by 1%, your consumption of X will increase by 1%.
Exactly right. If my income were to increase by 1%, consumption of good X would also increase by the same percentage, 1 to 1. Okay. So if my income rises by 2%, my consumption of good X would rise by 2%. If my income were to fall by 3%, consumption of good X would fall by 3%. Equal proportional changes. Okay. Now, do you remember some rule I told you for elasticities? What's a quick way of seeing that?
Well, because these exponents are multiplied together, not
Okay.
added.
Okay. Okay, not the exponents, but the variables are multiplied times each other.
Oh, yeah, sorry. I'm just going mistakes today.
That's all right, that's all right.
The exponent will tell you.
Yes, the exponent on I is 1. So if you have a multiplicative form where the variables are multiplied times each other like this, then the elasticity is just the exponent. Okay. So what is the price elasticity demand for good X? Let me be a little more precise. Let's call this the own price elasticity. What's the elasticity of X with respect to the price of good X? We'll call this the own price elasticity. Well, first of all, what's the formula?
Partial X over partial X
Right?
times dx over X.
You got it, Ian. Exactly right. Now, intuitively,